Okay, good morning. Happy Tuesday. January is just kind of flying by. It's crazy. Um, all right, so we're plugging away through chapter 1. Chapter 1 is huge. It takes so long to get through, so don't worry. But hopefully as we're going along, kind of things are falling into place, and we'll keep working in 1.3 today, and then we're going to go into 1.5, which is on equations, just to teach you a trick on factoring a specific kind of equation. And then we'll go back to 1.4 with that tool. It'll make it a lot easier. So, but let's start in back in 1.3, and so just as a little bit of review, we kind of ended off talking more about expanding and factoring. Expanding and factoring. So that's section 1.3. Oops. So I want to do just a couple of examples before we kind of get going from 1.3. So the one I was looking at was, I want to do 54, okay, where we have to expand this thing. And so if we have to multiply, then we're expanding this thing, and we're trying to get rid of all those brackets. Now, the reason I picked this one is because we've got these fractions in the exponents, right? And so what I want you to kind of think about is, okay, expanding is when we are expanding this expression and we're getting rid of brackets, whereas factoring is when we're trying to kind of smush things together and put things back into brackets, right? And so expanding is going big, and then factoring is the reverse. Maybe I'll write that down. Right? So expanding is when we essentially remove brackets. Okay? And just kind of make this expression large. Make the expression larger, just kind of more terms, but no brackets, right? Whereas factoring is the reverse. The reverse of expanding, right? So what we do is we extract all common multiples. Right, which we can also call common factors, right? So common factors, and that's where the term factoring comes from. Oops, I said factoring. And there. Make sure, okay. So, so factoring is the reverse. And at least for me, and also in my experience, expanding is something we can all kind of get on board with, and it's fine. Typically, it's a little bit easier, whereas factoring can be a little bit tricky, right? So we'll practice some expanding, but then also just remember that factoring is just the reverse, or just. You'll see what I mean later. So if we go to the 1.3 notes, like I said, I want to go through and do 54 as an example on expanding, and then just kind of as a teaser, right? Later on, we're going to be factoring out fractional exponents, right? And so just the way that we're going to expand things out, we need to be able to pull fractional exponents out, right, as common factors. So we're going to go both ways, and factoring fractional exponents can be kind of tricky, right? So we'll spend some time here. And then really, you've got tons of practice problems here. We won't have time to go through, very many of them, but you have the solutions. So try, pick a few in the beginning, pick a few in the end, see how it goes, right? So for expanding, let's see here. I'm not going to grab the whole blip because I'm just going to grab 54 here. So I'm going to do 54 for an example on expanding. So 54, we want to multiply x to the 1 over 4 times 2 times x to the 3 over 4 minus x to the 1 over 4. Okay. A couple of things we need to remember here is, okay, how do we multiply variables, right? So how do we deal with exponents? And then also we've got these fractions that we need to deal with. So we need to remember a couple of things before we head in here. But what we're doing is the same thing that we were doing last week, right? We're going to multiply this x to the 1 over 4 onto both terms. So this becomes, right? So just to show here, this x to the 1 over 4 goes onto each of these terms. And just to show the order, what I'm going to do is I'm first going to write x to the 1 over 4 out front and then times each of these terms. And then I'm going to switch them around and collect my x's so I can see them properly, right? So, but if you just went to the second step right away, that's fine. So I'm going to have x to the 1 over 4 times 2x to the 3 over 4. Technically it's plus, but if you went straight to minus, that's fine. So plus x to the 1 over 4 times negative x to the 1 over 4. Okay. So technically that's what's going on here, right? You're always adding these things, but then if you have a negative term, but this negative is just going to sneak outside and become a minus. So if you went straight to this next step, that would be fine. So here we have 2x to the 3 over 4 times x to the 1 over 4 minus x to the 1 over 4, x to the 1 over 4. All right, if you went straight to that, that's totally fine. Remember, right, if you have the same base, then you can combine those exponents, right, and make them on x, right? You can combine these exponents by adding them. Okay, so if you're multiplying the same base, you can add the exponents. So we have 2x to the 3 over 4 plus 1 over 4. Okay. And then minus, same thing going on over here, x to the 1 over 4 plus 1 over 4 in the exponent. Right, make sure you're showing that those are in the exponent. So this is from Exponent Laws, right, which we covered in 1.2. And then fractions, we also talked about probably, I think in 1.1, we've covered fractions, right? So when you're adding fractions, you have to make sure you have a common denominator, which we do 4 here. So then I can just add across. So what I get is 2x to the 3 plus 1, but I'm going to show that it's 4 over 4, just so there's no mystery here. Minus x to the, same thing here, I've got a common denominator of 4, so that's great. So 1 plus 1, which is 2 over 4. Okay. All right, so of course, 4 over 4 becomes 1, x to the power of 1. I'm just going to write as x. And then here I've got x to the power of 2 over 4, which I can simplify to 1/2, right? Remember what 1/2 is, that's the square root of x, right? So I'll write it out in 2 steps. 2 times x minus x to the 1/2, which is really 2x minus the root of x, right? If we remember all those things about fractional exponents, right? We're really talking about roots. Whew. Okay. So here, right, we've simplified this thing, we've expanded, gotten rid of the brackets, and so here, this is the expanded form. It didn't get any bigger, but we got rid of those brackets, right? So sometimes that's the case where it doesn't get any bigger because we're able to collect those x's, but we did expand it because we got rid of the brackets. Okay. Good. Let's see if I can grab a factoring example before we keep going here. Let's do one of these. So, I can't remember which one we did last day. Let me just check, because we ended on one, didn't we? We did 64. So let's not do 64. Let's do 65, and then just for some more practice, let's do 68 as well. Oh, okay, awesome, 68. Whew. Hey, good thing I snuck it in there. Something about 68, awesome. So I'll do 65, and then thanks for the reminder, Sonia. Good. 65 for a warm-up, and then we'll do 68. How about? So we've got y times y minus 6 plus 9 times y minus 6. Now, when you read it out, right, you can kind of hear that y minus 6 and y minus 6 are repeating, right? And so you've got a common factor of y minus 6, which is a little bit weird, and that's why I wanted to look at this one, right? If you treat y minus 6 as if it's one thing, you can extract that to the outside, right? So what you get is you have y minus 6, just kind of crane that out as if it's one thing out front, and then inside the brackets, well, here you've got y times y minus 6, right? So we're going to write that down. And then here, plus 9 times y minus 6. We pulled the y minus 6 outside. So here we do plus y. Plus 9. And then that's factored. Okay. So if you wanted to expand this out, just to double check that you have kept everything the same, right, which you should be doing, just remember that you treated y minus 6 as if it's one thing. So when you multiply it out, you don't need to take y times y times 9. If you did, you would also have to expand this left-hand side to check it to make sure, right? And so here, this is the factored version, and there's nowhere kind of more compressed that we can go. So let's do 68. Negative 7x to the 4y squared plus 14x times y to the 3 plus 21x y to the 4th. Okay. So now, and I probably should have not written so lofty here. I'm going to move it over there. Okay. Just so I have room to write on the right-hand side. So we've got coefficients, right? On each of these terms, looks like they're all multiples of 7, right? So you want to scan your coefficients. Are there any common multiples that I can pull out here? It looks like there are, right? So that's good. Well, I'll keep that on the back burner. Then I'm going to go through and I'm going to say, okay, I've got x's. I've got an x in each of these terms. So we can always extract the lowest power of x, right? So if I scan here, x to the power of 4, x to the power of 1, x to the power of 1, which means I can extract an x to the power of 1. Then I see that I have these y's, right? And so same idea, I can always extract the lowest power of y from each of these terms. So here I've got y to the power of 2, y to the power of 3, y to the power of 4. So I should be able to extract a y to the power of 2 from each of these terms. So we'll be able to pull out a 7, a 7, a 7. Okay, great. So what I'm going to do is I'm going to write that out front here, 7. And then I'm going to go through and I'm going to pull out a common multiple of x and y to the power of 2, right? So x is the lowest power of x, and y to the power of 2 is the lowest power of y. Now, I need to figure out what 7xy squared needs to be multiplied by to become negative 7x to the 4th y squared. Okay? So I definitely need a negative, and I need to bump up my x from x to the power of 1 to x to the power of 4. So what I have is I have negative x to the power of 3. Oops, that doesn't really look like a 3. There. And you can check it, right? So if you multiply this out, you should end up at negative 7x to the power of 4, y to the power of 2. Right? I already have the 7 and I have the y to the power of 2, so the one that's missing is negative x to the power of 3. Okay. Then I go on and I do the same thing with the second term, right? What do I need to multiply 7xy squared by to get to 14xy to the 3? So I've got the x, I've got 2 of the y's, and I've got 7. So I get plus 2, right? 7 times 2 is 14. I've got the x under control, and I need another y here. Y times y squared makes y to the 3. Thinking about those exponent laws, right? Same idea, right? From 21, what do I need to multiply 7xy squared by to get to 21xy to the 4th? So again, I'm going to have plus 3y to the power of 2. Yeah. Now what I want you to do is, okay, so that's here, I've pulled out these common factors. Now just have a scan here and see if there's anything that you can rearrange to simplify things. In this case, no, I've got an x here, I only have y's here. I could pull out a common y here, but I'm going to leave it, right? So one thing you could do is you could factor inside these brackets by pulling out a common y, but I'm just going to leave it at that, right? So I'm going to leave it here, and that's good. Good for that. Any questions about that one that I got you to do on your own, 68? That looks better. Awesome. Okay, so we're chugging along, we're expanding, we're factoring. If you're anything like everyone else, you like expanding more than factoring, but a lot of the time we're going to need to factor things, usually because it's going to be our way of simplifying things, right? So usually we factor to be able to cancel stuff. So that'll be really useful later on. Okie dokie. So we're here in 1.3, okay? So there are some special factoring formulas. I actually don't find these that helpful, but if they do help you, right, what you would need is you would need to be able to recognize the format, right, of each of these special factoring formulas. And then you've got the shorthand for what they factor to, right? But you would need to assign values to A and B in each case, right? And so if you are able to identify an expression of the following forms, you may use the special factoring formulas. Okay. So what I mean by that is if you recognize something as a squared minus b squared, or you can rewrite it as something like a squared minus b squared, how you can factor that is a minus b times a plus b, right? Same thing if you recognize something as a squared plus 2ab plus b squared, you can factor that as a plus b squared, right? And so I want to do one example, but like I said, it kind of hinges on being able to recognize these, and that can be kind of difficult. So it's not something that I pretend to do all the time, right? So just if you see something, right, that looks familiar, that looks like one of these, then absolutely flip back and have a look. Okay, can I make it match one of these special factoring formulas? And then that'll give you a leg up on factoring. But as you'll see, it's not always obvious, and it's probably easier to just brute force it. But it is one of the ways that we can factor. So let's do an example. Let's see here. Well, let's start nice and slow here at 77. So if you have 9a squared minus 16, so this is what I mean. It's not always obvious that you can use a common or a special factoring formula. Right, but let's do 77. Oops, 99. 9a squared minus 16. Okay. I only have two terms, so I'm restricted to the first one, the fourth one, or the fifth one. But the fourth and the fifth one have a to the 3 and b to the 3, and I only have powers of 2. And the reason I say that is because 9 I can rewrite as 3 to the power of 2. Same thing with 16. I can rewrite it as 4 to the power of 2. So it does require you to kind of be able to recognize squares, right? 9, 16, 25. Okay, so here we can rewrite this in the form of a squared minus b squared. Okay. Where a, in this case, right, if I'm just saying, okay, 9a squared has to be a squared, okay, then I need to extract a square from 9a squared, where a squared, I should start there, is going to be 9a squared. I'll write out what the factoring formula is, right? So a squared minus b squared is going to become just a minus b times a plus b. So notice that I need to have a and b on their own, not just a squared and b squared. So here I'll write that out as is going to be a minus b times a plus b. So a squared is going to be 9a squared, and then b squared is going to be 16. Okay. So from here, we need to make the leap that, okay, well, if a squared is 9a squared, then a must be 3a, right? If I bring in that square onto each of those terms, so here I'm going to go, okay, then a must be 3a. And you should check it, right? If you have a squared, then you've got brackets around this 3a, right? So then you have 3 squared times a squared. Well, that's 9a squared, right? So it checks out. Okay. Same thing here. That means that b is going to be 4. 4 squared is 16. So that checks out too. Okay. So now that you have your a and b, you're going to construct this factor just by picking up your a, which is 3a, so replacing all the a's with 3a's, and then it's confusing because it's a lowercase a versus an uppercase a, and then replacing your b's with 4. So what we get is we get 9a squared minus 16 is going to be the same as 3a minus 4 times 3a plus 4. What I want you to do, and for me, like I said, I have never felt confident factoring, right? It's just going to be a matter of practice. But even though I've done, tons of factoring, I still doubt myself, and that's okay. It's probably good. It's probably healthy. So, but what I always do is just quickly expand things out just to make sure that it simplifies to where you started, right? And so here, check the factoring by expanding, right? And so what I'm going to do is I'm going to have 3a minus 4 times 3a plus 4. And then I'm going to expand that out, right? Remembering you take 3a times 3a plus 3a times 4 plus negative 4 times 3a plus negative 4 times 4, right? So expanding, you just work methodically and expand this thing out. So I get 3 times 3 is 9a squared. Off to a good start here. And then plus 12a minus 12a, and then minus 16. 4 times 4 is 16. Okay. So we see here that 12a minus 12a is going to go away, and I'm left with 9a squared minus 16, which is where I started. Phew, right? So just always, if you're doubting your factoring, then definitely just take that little bit of time to expand it out and just convince yourself that your factoring was good, especially if you're going to use it to cancel things later on, right? You want to make sure that it's legit. So good. Okay. So like I said, just kind of seeing something like this, right? So like 83 here, x squared plus 12x plus 36, seeing something like that and translating it to equation 2, I actually find a little bit tricky, right? Because you need to figure out what a is, you need to figure out what b is, and then translate it into one of these special factoring formulas. I find that difficult. And so what I want to do is for quadratics, which is something which has an x squared, an x, and then a constant, that's why we're diving into section 1.5, so that we can have tools for factoring a quadratic without using the special factoring formulas necessarily. So, but try these, right? Try to match these up with the special factoring formulas, because the more you do, the quicker you'll kind of see the patterns and you'll be able to apply these. But like I said, they're not always obvious. Yeah. So what I do want to spend time on is factoring fractional exponents. Okay, so to factor fractional exponents, we need to work with exponent laws, but also because we're dealing with fractions, right, we've got our fraction rules, right, that we have to deal with as well. So to factor fractional exponents is not different than just factoring in general. We'll still only be able to extract a common factor of the lowest power of x, right? So whether that be fractions or not, that still applies. So let's go back and write a note here. To factor fractional exponents, the same rule applies. We will be able to factor out the smallest power of x. We will be able to factor out the smallest power of x. Okay, so if that's a fractional power, that's fine. You can just kind of ignore that. Just remembering, you know, fractions behave a little bit differently, right? So I'll show you an example. Usually there'll be a negative fraction to extract. And I included, it works through an example here, just so you have a couple more to look at besides the ones that we do. So let's start with 91, nice and slow. And then we'll move on to some other ones here. So 91, x to the 5/2 minus x to the 1/2. Now here's the pickle, right? For me, well, this one it's simple, right? But you need to figure out which one is smaller, 5/2 or 1/2, right? 5/2 or 1/2, 1/2 is probably smaller, right? But if you had to check it, you can just use your calculator, right? So just go 5 divided by 2, that's 2.5. 1 divided by 2 we know is 1/2. So that's the smaller one, right? And so just convince yourself, right? This is the smallest power of x. Okay. So that means that we can extract an x to the power of 1/2 from each of these terms. So therefore, we can factor out a common x to the 1/2. Okay. How are we going to do that? Okay, so we need to remember exponent laws, right? Exponent laws say that, okay, I can split this thing up, x to the 5/2, I can split it up into x to the 1/2, which is what I'm trying to pull out, times x to the power of something, right? So I need to figure out what 5 over 2 minus 1/2 is, okay? So we've got, we need to extract 1/2 from 5 over 2, right? Or rewrite 5 over 2 as a sum of 1/2 and something else, right? Just because of exponent laws. So what you're going to do is you're going to do 5 over 2 minus 1/2, and usually this calculation happens kind of on the sidelines, right? Somewhere on the edge of your paper or something like that. So it's not typically part of the calculation, although it can be, but you would be working up here in the powers, right? I just want you to see what's going on, and then for the next example, I'll do it properly. Okay? So here, 5 over 2 minus 1/2. Keeping in mind, we've got fractions, right? So I need to have a common denominator before I can subtract them. I do, so that's good, right? If you didn't, you'd have to force that common denominator. So now I've got 5 minus 1 is 4 divided by 2. Okay. I'm going to keep it as 4 divided by 2, even though I could simplify to 2. I'm going to do that. I'm going to leave that till the very end, just to emphasize that that this is related to the 1 over 2 and the 5 over 2. So what this means is I can replace 5 over 2 is the same. So if I add 1 over 2 to the other side here, 5 over 2 I can rewrite as 4 over 2 plus 1 over 2. Okay. Okay. So now we take that information and we put it up here. Right, and so here, let's start this problem now. I've got x to the 5 over 2, minus x to the 1 over 2. I can rewrite that as, so what I'm going to do is I'm going to rewrite 5 over 2 as 4 over 2 plus 1 over 2, right, to get that common power. So I've got x to the 4 over 2 plus 1 over 2 minus x to the 1 over 2. Because I had to tease out that 1/2, right? So now what I can do, right, if I'm adding exponents, what that means is working backwards, right, from expanding, right? Now, if I'm adding the exponents, it means I have the same base being multiplied. So what I can do is I can rewrite this as x to the 4 over 2 times x to the 1/2 minus x to the 1/2. Now it's obvious that I've got that common multiple of x to the 1/2. Okay. So now I can factor that out to the outside, and so I get x to the 1/2. Oops, that doesn't look like 1/2. Times x to the 4 over 2. Now, you can simplify that now if you want to. I'm going to keep it as 4 over 2 just for another step, but it's just to emphasize what's going on here. So I've got x to the 1/2 times x to the 4 over 2 minus x to the 1/2, which is really x to the 1/2 times 1, right? So minus 1. Being really careful that you retain this 1 here, right? So that when you expand this out again, you end up where you started. Right? So now I can simplify this x to the 4 over 2 to just be x squared. So now I get x to the 1/2 times x squared minus 1. Good. So a little bit tricky, right? Because we need to remember how exponents work, how fractions work, right? And so especially tricky when we have negative exponents, right? So let's do 93. How about? Just because it looks, I don't know, it doesn't really matter, but any questions before we get into 93? I'm going to just grab it here. Oops. So I don't have to try to remember those fractions. Okay. All right. So here, the smallest power of x, right? We've got a negative exponent, -3/2, and a -1/2. Okay. And then a +1/2. Now, you might want to use your calculator, right, to figure out which one is the smallest of -3/2 and -1/2, right? -3/2 is -1.5. Just make sure, yes. And -1/2 is -0.5. So this is my smallest power of x. So that's what I need to extract from each of these powers, right? Rewriting the powers or the exponents as something related to -3/2. Okay. So I have to be really, really careful with the -1/2, right? Dealing with negatives. So I'm pulling out a -3/2 from each of these values, right? And so it can get a little bit tricky, but what I'm going to do is I'm going to try to do it properly. And by properly, I mean just rewriting the math in the exponents as I go along. So what this is going to look like is x to the -3/2 plus 2x to the negative, I'm just going to rewrite it out here, -1/2 plus x to the 1/2. Okay. So here I've got x to the -3/2, and that's what I'm going to pull out from each of these terms. So I can kind of ignore this first term for now. And then I need to rewrite x to the -1/2 as x to the -3/2 times x to the power of something that's going to simplify to -1/2. So again, let's just remember how these exponents work, right? I need to add something to -3/2 in order to get to -1/2. Okay, so a little bit tricky. So this is going to be x to the -3/2 plus 2x to the power of, how should I write this so it's nice and clean? -3/2 times x to the power of what? Okay. Maybe that's how I'll write it for now. You might have a different way of doing it, right? Because -1/2 minus -3/2 is going to be what? Dealing with those negatives, right? I've got a common denominator, so that's good. So I've got -1 plus 3 puts me at 2/2. Okay. So that's what I've got here. And you can just double check it, right? So check your work. If you have x to the -3/2, so just double checking here. times x to the 2 over 2. That's going to be x to the negative 3 over 2 plus 2 over 2. Which if I simplify this, right, I should get negative 3 plus 2, which is negative 1 over 2, which is exactly what we want. So this is x to the negative 1 over 2. Okay. So this question mark is going to be 2 over 2. Okay. Want you to do the same thing with x to the power of 1/2. I need to pull out a negative 3 over 2 from 1 over 2. So replacing the negative 1/2 with just positive 1/2. Here we go. So plus x to the negative 3 over 2 times x to the power of what? Okay. And here, I need it to be 1/2, and I need to pull out, minus negative 3 over 2. That's not a 2. 1 minus negative 3 puts me at 4 over 2. And you can just double check that, right? And make sure that 4 over 2 minus 3 over 2, yeah, puts me at 1 over 2, which is where we want to be, right? So this becomes x to the negative 3 over 2 plus 2x to the negative 3 over 2 times x to the 2 over 2 plus x to the negative 3 over 2 times x to the 4 over 2. Okay. I always like to write out the common factor before I actually factor it out, right? It just makes it easier for me to see what should be pulled out to the outside and what should stay inside the brackets. So now if I go through here and I have x to the negative 3 over 2 on the outside, well, to get to x to the negative 3 over 2, I need to multiply by 1. And then plus 2 times x to the 2 over 2 plus x to the 4 over 2. Okay. Just going through and seeing what I need to multiply x to the negative 3 over 2 by to get to each of these terms. Now, of course, I can simplify 2 over 2 to be a power of 1 and 4 over 2 to be a power of 2. But I like to see those fractions before. X to the negative 3 over 2 times 1 plus 2x plus x squared. And then we're done. So again, you could pull out a common x here. I wouldn't worry about it. I wouldn't do that. But here you've extracted this common factor of x to the negative 3 over 2. So the hard part is figuring out how to break up the other exponents into two fractions that would add to what you need from the one that you're extracting, right? So that can be a little bit tricky and definitely requires a lot of practice. Let's do another one. Which one do I want to do? Let's do 96. Again, I'm just going to steal it here so I don't have to remember it. So I've got x to the negative 1/2, and then I've got x plus 1 to the 1/2. Okay, So then I've got another x to the 1/2. Okay, so I've got x's and factors of x plus 1. So now I'm going to have to work with both the x's and the x plus 1's. And again, I'm only able to extract the smallest power of x and x plus 1. So just to highlight here, I've got x and x, and then I've got x plus 1 terms and x plus 1 terms. Okay, so we'll be able to extract the lowest power of each of these, right? So the lowest power of x is -1/2, right? Because this one's positive, so that's larger. And we're just talking about on the number line, right? So the smallest number is the one most to the left, right? Especially when you're dealing with fractions, it might be easier just to translate those fractions onto a number line and then pick the smallest one from there, if it's not, jumping out at you. Here we've got a power of +1/2, and here we've got a power of -1/2. So I'll be able to extract an x plus 1 to the -1/2. So we will be able to extract, right, or factor out x to the -1/2 times x plus 1 to the -1/2, right? Which are the lowest powers of each. Okay. So I don't need to manipulate the first term to pull out an x to the -1/2, but I do need to manipulate the second term to figure out what I can extract. Now the 1/2s are actually kind of nice, because what do you need to add to -1/2 to get to +1/2? You need to add 1, right? And so 2/2 is plus. So x to the 2/2 plus or times x to the -1/2 blah, 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 gives me x to the 1/2, right? So the 1/2s are actually kind of fun to deal with. And then same thing here, if I need to pull out an x to the -1/2 from a +1/2, then I need to be adding 1/2, or sorry, a full unit, 2/2. So we can rewrite this as x to the -1/2. Actually, I'm just going to copy the expression down here. X plus 1 to the 1/2 plus x to the 1/2 times x plus 1 to the -1/2. I'm going to scoot this over a little bit so I can work to the right of it. So what I'm going to do now is I'm going to just do the math as I would if you're solving this problem, right? So we've been kind of going off on different tangents here. So x to the -1/2 times x plus 1 to the -1/2, that's the one I need to extract, right? Times x plus 1 to the 2/2. Okay? And just make sure that when you multiply these together, the same base, right? -1/2 plus 2/2 puts you at 2 minus 1, which is 1/2. Checks out, right? I need to not write so large. So same thing here, plus x to the -1/2 times x to the 2/2 times x plus 1 to the -1/2. Okay. So just be careful, right, when you rewrite these out, right? And you can always just check, okay, if I've got the same base, then I should be able to add my exponents right? And end up where I started here, x plus 1 to the positive 1/2 and x to the positive 1/2, negative 1/2 plus 2/2, which is just 1, which is what we decided. Right? So now I'm able to pull out the common factor of x to the negative 1/2 times x plus 1 to the negative 1/2. X to the negative 1/2 times x plus 1 to the negative 1/2. And then I'm going to use square brackets just to emphasize that all that is multiplying everything inside here. I've got this x to the negative 1/2, and I've got this x plus 1 to the negative 1/2. The only thing I'm missing here is x plus 1 to the 2/2. Again, I'm going to write it with 2/2. If you just went to x plus 1, that's fine. But I just want to emphasize that they're the same. Plus, okay, so I've got this x to the negative 1/2. I need to multiply by x to the 2/2. And then I've got this x to the x plus 1 to the negative 1/2 already. So the only thing that's missing here is x to the 2/2. Okay. Now I can get rid of some of these powers inside those square brackets. So this becomes x to the negative 1/2 times x plus 1 to the negative 1/2. Times x plus 1 to the power of 1 plus x to the power of 2/2, which is also just 1. Right? Turns out we can simplify this even further, right? And say, okay, well, these brackets around x plus 1 aren't doing anything anymore because we're just adding inside. So then we get x plus 1 plus x making 2x plus 1. So this becomes x to the negative 1/2, times x plus 1 to the negative 1/2 times 2x plus 1. We did it. Okay. So definitely a little bit sneaky, right? Dealing with those fractional exponents. But just remember, the rules are the same. You can pull out the smallest power. It's just going to be a little bit more work, right, than dealing with whole powers or whole exponents. Okay, great. So let's see here. So definitely give all those oh, okay. So here, oh, because you've got, okay, so the question was, okay, how do you simplify, or essentially, I'm paraphrasing, but x plus 1 to the 2/2 is x plus 1, right? And so, and then we're adding x to the power of 2/2, but that's just x to the power of 1, right? So now we're not multiplying inside here because we're just adding across, right? So we've got x plus 1, which isn't, it doesn't need to be contained inside these brackets anymore, right? You're going to have x plus 1 and then plus x. So then, cool, sounds like kind of maybe cleared things up, but you've got x plus 1 and then plus x. So inside these brackets, you want to make sure that you're not multiplying, right? Because you're actually just adding, which is weird because we've been multiplying all along. But here, right, this just becomes 2x plus 1. Right? Make sure that cleared things up a little bit, at least. And I think, I don't know if that cleared it up, Wendy, or but what we wanted to do is we wanted to factor these things out. So then if you wanted to expand it, no, so you're just going to leave it like this. So because we're factoring, you want to try to kind of have as many things as possible being multiplied together, right? And just kind of condense like this. So because we're factoring, you want to leave everything like this, kind of all bracketed up and ready to be multiplied and expanded. Like I said, pretty tricky fractional exponents, but I will make you do them. So it's worthwhile kind of sitting down and making sure you have them under control. And they'll come up on your assignments too. So, and on the test. So just make sure that you have them kind of under control. But yeah, definitely just require practice. Okay, so, and there are lots of other problems here that you can work through and just kind of try. I don't think there's any more fractional exponents here that I can see, but that's okay. We can try factoring some other things. And in the next section that I'll show you some more factoring tricks. So, so we'll have a couple of tricks up our sleeve. So another way that we can factor is sometimes if you have at least 4 terms, you can factor by grouping terms. Now, I'll show you what that means, but I'll just write it down here. So if we have at least 4 terms, in our expression, we can factor by grouping terms. So for example, what that might look like, okay, is something like this. So here, 1, 2, 3, 4 terms, right? And so we can try just grouping and regrouping these terms to get something that kind of looks nice. So the trick is going to be to figure out how you want to group things. And remember, brackets around adding and subtracting don't do anything, right? It's only if you're multiplying around those brackets that they actually end up doing something. So for example, let's try 86 just for fun. Okay, so now first thing you want to do is 1, 2, 3, 4. Okay, I've got at least 4 terms. I do see sometimes people want to try just factoring by grouping because it's so fun. No, but it's kind of the most, yeah, it's the most fun way of factoring is factoring by grouping. But what you need to remember is that you have to have at least 4 terms. So we can't do it if we just have 3 terms, which is what we usually have, right? And so here, if we've got 3x to the power of 3 minus x squared plus 6x minus 2, right? First thing I'm going to write here is 4 terms, check. Okay, so we can try grouping. There are a couple of ways that you can group things. First one I see is maybe I'm going to try to group my 3x to the 3 and my 6x together. Okay. and see if I can extract some common multiples, right? The other way that we could do it is we could group. Now, often this will work too, is if you just group the first two together and then the second two. So let's try it a couple of different ways, and we'll see where it gets us, right? Sometimes we have to be a little bit sneaky with how we do things. So you'll see what I mean. 3x to the 3 minus x squared plus 6x minus 2. So my go-to would be to group this one, these two terms, and these two terms. You can see the problem. If you only have 3 terms, then you'd be trying to extract one factor out of one thing, and it doesn't really do anything. So what I'm going to do is I'm going to rewrite this, right? Putting brackets around these won't do anything because we're just adding and subtracting, right? But it does help us visualize, okay, here's a group and here's a group. So what I'm going to do is 3x to the 3 minus x squared plus 6x minus 2. You always want to make sure that when you're putting these brackets, right, especially with this plus here, when I add it in here or expand it out, it can't change the equation on the left-hand side, which it doesn't in this case, right? But if you had a negative here, you would have to extract a negative from both terms. Okay. So now what I'm going to do is I'm going to focus inside each of the brackets to see what I can extract. In this case, I can extract a common x squared, right? My lowest power of x. So what I get here is I get x to the power of 2 times 3x minus 1. Okay. Now these brackets are doing something, right? Because they're being multiplied by x squared. Plus, and then so here, all I can extract is a common multiple of 2. Okay, so what I get is I get 2 times 3x minus 1. Just being really careful. So now, what's not obvious, maybe right away, is that you've got this common multiple of 3x minus 1. So what I'm going to do is I'm going to factor the 3x minus 1s outside, and what that becomes is now I have 3x minus 1, and then I'll use square brackets just to emphasize that that's all times, and then x squared plus 2. Kind of weird, right? You don't have to use square brackets, you can use round brackets, but I just like to emphasize that it's 3x minus 1 times x squared plus 2. Remember, this only works if you have at least 4 terms, right? So, and sometimes, I mean, your grouping might not work out that well. So another way that we could have done this and said, okay, well, I can group my 3x to the 3 with my 6x, and then I'll be able to extract a 3x, right? So let's try that instead. Or we could try another grouping. So 3x to the 3 minus x squared plus 6x minus 2. So now what I'm going to do is I'm going to group these two and group these two. Okay. So first thing I'm going to do is I'm going to rearrange these terms and say, okay, well, I'm not changing anything by changing the order. 3x to the 3 plus 6x minus x squared minus 2. Okay. But I can put brackets around these and just be careful with this negative here. Like I said, you can pull out the negative, but it's going to be part of when you're expanding it back in, right? So what we can get is we can get something like, okay, I can pull out a common multiple of 3x, we said, right? So I can rewrite this as 3x times x squared plus 2. Okay. And just check when you expand this in here, you should end up at the same thing where you started, right? Then from here, I'm going to extract a negative 1, right? So minus, ignoring the 1, because usually we don't write multiples of 1, times x squared plus 2, right? Once I've extracted this negative here, I need to extract it from both of the terms, and that's a really common mistake where you forget to pull out that negative from the negative 2. So now, notice, again, we've got this situation where we have this common multiple of x squared plus 2. So again, I'm going to kind of airlift that outside and say, okay, x squared plus 2 times 3x minus 1. Yeah. You can see that it doesn't actually matter how you rearrange things. We're going to end up at the same factor, right? Notice we end up with the same factors as before. Good. Okay. So, what I want to do, I want to give you guys a little bit of a break before we get into section 1.5, but 1.3, really solid kind of practice with factoring. It's going to come up throughout the term. So if you ever find like you need more practice, then just go back to section 1.3 and do a couple of problems there. But we'll practice factoring as we go. So let's have a break until 9:20, and then we'll pick it back up. So I guess a 7-minute break, just enough time to grab some coffee. Okay. Resume. Okay, here we go. So we're going to do this slightly out of order. Okay, so we will do section 1.5 before 1.4. Okay. And it's only because it's going to be a way for us to introduce how to factor quadratics. So, but before we do that, let's just talk about section 1.5. So 1.5 is kind of mysteriously called equations. Okay. So 1.5 is called equations, and let's just talk about the difference between an equation and an expression, because that's not always obvious, right? So here, what we've been dealing with so far have been expressions, right? Expressions, so factor the expression because they don't have an equal sign, right? An equation has an equal sign, equal, equation, right? And so that's the difference between an expression and an equation. It's not a lot, but having that equal sign means that we can move stuff around, right? Here, we create this equal sign by manipulating the expression and keeping it the same on both sides, right? By just slowly manipulating. So that's how we create this equal sign, but we're not given an equal sign initially, right? And so far, oops, I guess it's just down here. So far, we have worked with expressions, right? Things like x to the power of 3 plus 2x squared minus 4x plus 1, right? Expressions do not have an equal sign. Right. So now we introduce equations which have an equal sign. So now we introduce equations which have an equal sign. With that equal sign, we're going to be able to solve for x, right? So we'll be able to solve equations. So with the equal sign, we will be able to solve equations. And I know that's kind of cryptic for you probably right now, right? Solving equations, to solve equations. But solving just means solving for the variable, right? Most often that variable is x, right? So solving means solve for the variable, usually x, that makes the equation true. Oops. Okay. So when I say solve the equation, right, you have to solve for the variable, and if there are multiple variables, then I need to say solve for r, or solve for x, or solve for y, or whatever, right? And so solving for these for variables just means you have to rearrange things to get that variable on its own. And we'll start and we'll talk about just two different types of equations. There are lots of other equations, but our main players are going to be linear equations, which are equations of straight lines, and quadratic equations, which have this kind of parabolic shape. If you remember, you've probably seen parabolas before, x to the power of 2. So we will start by introducing two main equations. The first one is a linear equation. A linear equation is a straight line, right? And so a linear equation is a straight line. If you're thinking about it graphically, and it's going to have the form y equals mx plus b, right? Where m is the slope, right? And you might remember mx plus b, y equals mx plus b. M is the slope and b is the y-intercept. And I guess I should use the same. B is the y-intercept. And then we leave x and y as x and y, just open for plugging in any value of x and y, or any combination of x and y, to figure out Usually we plug in a value of x to figure out what the value of y is, right? But they're going to be ordered pairs on this straight line. Okay? And we'll talk more about lines later in chapter 1, so that's why I don't want to spend too much time here, but being able to recognize this form of the equation is really important, right? Essentially, you've got the highest power of x is 1, right? So here, for linear equations, notice the highest power of x, oops, the highest power of x is 1, okay? That's what makes it a linear equation. The second equation that we're going to be dealing with is a quadratic equation, and quadratics come up so often, and so that's why I want to talk about the quadratic, but also how do we factor quadratics. Okay? So eventually we'll talk about factoring quadratics, but for now let's just talk about the form. So the quadratic equation, which is a parabola that kind of looks like, oops. And we talk more about the graphs of these things later, but it's going to look kind of like this. Right? So that's a parabola. A quadratic equation has the form y equals x squared, or rather ax squared plus bx plus c. Okay, notice that each of these have a coefficient, right, except for this last one, which is just a constant, but the highest power of x is 2, right, and that's what makes it a quadratic equation. Once you've simplified everything, right, then if you have a quadratic, what you have is the highest power of x is 2, and so being able to recognize a quadratic equation is really, really important. Okay. So here I'll say, notice the highest power of x is 2. Right? So we're working our way up here. This is where we're going to stop and pause for a little bit. We're going to talk about how do we solve linear equations, how do we solve quadratic equations, okay? But just being able to recognize these things is going to be really, really useful. Okay? So if we go back to our 1.5 notes, right? There's a couple of notes here. I don't know, it got small when I brought it in, but that's okay. So here we've talked about linear equations, right? I've already made notes of this here. You can, so in y equals mx plus b, you could subtract the y over and have it equal to 0, right? So that's fine. So what I want to do is actually want to start down here and work through just a couple of these equations, just being able to solve for a variable, right? Get warmed up here. And then what I want to do is I want to move through and solve some linear equations, right? And so sometimes it might not look linear. So the given equation is either linear or equivalent to a linear equation. Now, this type of question is definitely something that I'll put on test 1, but also on the final, right? And so we need to be really good at working through. So just kind of star 13 to 30 and make sure that you're able to work through all of these. So I'll do a quick selection, and x to the power of 4. We will deal with that, but usually what happens is you'll be able to factor out an x to the power of 2, and then you'll have a quadratic to deal with. So yeah, so usually having the tools for a linear and a quadratic set us up to be able to deal with kind of bigger equations too. So we will have to deal with x to the power of 4, but you'll be able to kind of tease away a quadratic equation. So cool. Good. So for now, let's just focus on some linear equations, and I want you to make a note in your notes, right? If you don't have time now, before the test, right, go through these questions here, and before the final, right, review these, because I'll have something very similar to this on both the test and the final, right? So something like this will come up, right? But let's do some of these problems before that to get kind of warmed up, right? So just solving for some variable. So first thing you're going to notice is, okay, we've got equal signs everywhere here, right? So here we have these equations, and that's why we'll be able to solve for things, right? And so let's do, so the first one I want to do, I usually like to start with 34, okay? Just because it's a nice warm up dealing with fractions and just kind of how do we solve for different things. So notice that we've got R1 and R2. So R subscript 1 and R subscript 2. And these are all different variables, right? As soon as we have different subscripts on there, they're going to be different variables. And here we're told to solve for R1. So 34, 1 over R is equal to 1 over R subscript 1 plus 1 over R subscript 2. And we want to solve for R subscript 1. Okay. So what that means is I want to have R subscript 1 on one side, and usually what you'll notice is I like to have what I'm solving for on the left-hand side. If not right away, then kind of sometimes I'll just kind of massage things until what I'm solving for is on the left and everything else is on the right. Right? So that's something that you'll notice as we go through these problems. But what you want to do is you want to try to get R1 on its own. Now, R1 is different from 1 over R1. So I need to move this R1 kind of away from this 1 over R1. Now, there are a couple of ways that we can do this. Okay. One thing that I need to remember is that I'm not allowed to just multiply this R1 over here, right? Because in order to do that, I would need to extract an R1 from R2. And now, there's no easy way for me to do that. So what I'm going to do is I'm first going to move this 1 over R2. I'm going to move it over to the left-hand side, right? So now I've got 1 over R1 is equal to 1 over R plus 1 over R2. Okay? Whatever you do to one side, you have to do to the other. And so when you're moving things over to the other side, you basically do the opposite. So here, 1 over R2 is being added. So in order to move it over, I need to subtract it. Okay? So what this looks like is I have 1 over R minus 1 over R2 is equal to 1 over R1. I'm not doing a good job of stacking my equal signs, but what you'll find is that you should try, and here right off the get-go, I wasn't able to, but you should try to stack your equal signs, right? Just to see how things change on both sides as you move through the problem. Obviously, it's not life or death, but it is something to try for, right? I limited myself with the space I gave myself here. So, okay, so what I want to do is I want to solve for R1. Now, in order to shake out this R1, what I need to do is I need to multiply both sides by R1, right? Here on the right-hand side, it's being divided by R1. So in order to move it to the left-hand side, I need to multiply everything by R1. Now, that's not going to be very nice, okay? Because we've got this fraction here. In fact, we've got a fraction minus a fraction, and they don't have a common denominator, right? I don't want you to be tricked into thinking R and R2, right? You don't have a common denominator. Your common denominator would have to be R times R2. Right? So what you have is you can multiply this over here, but that's going to look like R1 times 1 over R minus 1 over R2 is equal to 1, right? Keep this 1 here. That's not going to change, so it's equal to 1. Now, there's a sloppy way we could do it, and a more elegant way we could do it. So what we could do, because we're just solving for R1, what we could do is we technically have R1 times this mess here, right? So instead of finding that common denominator and all that fun stuff, what I could do is I could just divide it over to the right-hand side, right? But what I'm going to do first is I'm going to simplify this to be one fraction, right? One fraction with a common denominator. And then I'm going to move it over by dividing. Right? So this becomes R1 times 1 over R times R2 over R2, right? Forcing that common denominator, minus 1 over R2 times R over R is equal to 1. Right here, I'm forcing a common denominator, of R2. R2 is obviously not R squared, right? So you can't do that, but just treat them as their own things. Okay, so, right, this trick of forcing the common denominator, we're going to use so much, right? So if it's still kind of murky, then go back and look at those fractions in section 1.1 and make sure that you have those under control. So this becomes R1 times R2 over R2 minus R over R2, R over R, sorry, R2 times R is equal to 1. Maybe if I'm gonna practice what I preach here, try to stack my equal signs, not a big deal. Okay, so now that I have this common denominator, I can combine the numerators over that common denominator. So what I have is I have R1 times R2 minus R over R2 is equal to 1. Okay. Now, what I'm going to do is I'm going to, right, I'm trying to solve for R1. And so to try to move this over here, right, I need to divide both sides by this term here, R squared, R2 minus R over R2. So I have R1 is 1 divided by this big nasty thing, R2 minus R over R2. Okay. Notice that we've technically got a fraction over a fraction, right? 1, you can always rewrite as 1 over 1, right? So now you've got a fraction over a fraction, which you can flip the denominator and multiply, right? So R1 is going to be 1 over 1 times R2 over R2 minus R. Multiplying fractions, you can just smush them together. So then R1 becomes R2 over R2 minus R. Good. All right. Good. So a little bit tricky, right? But just kind of focus on which variable you want to solve for, and then rearrange based off of that. So let's do 38 as well, only because this type of format is going to come up quite a bit. Yeah, so let's do 38. I'm going to copy it because I'll never remember that. Oops. Okay. So I've got a plus 1 over b is a minus 1 over b plus b plus 1 over a, and I want to solve for a, right? So I've got a's kind of everywhere, and what my goal is going to be is I'm going to try to collect all my a's to one side and all my everything not a's to the other side, right? So keeping in mind that for fractions, in order to combine them, right, I need to have a common denominator. So my first thing I'm going to do here is I'm going to force a common denominator at least on the right-hand side. Ultimately, I'll probably end up doing it on the left-hand side as well, but for now, I'm just going to force a common denominator here because that's where I need it, right, in order to add these fractions, because I slowly want to try to shift my a's over to one side. So I have, a reminder for my next class. Okay, that's good to know. A plus 1 over b is a minus 1 over b. And I'm just going to go, because I'm kind of short on time here, I'm going to force the common denominator of b times a, or ab if you prefer, right away. So I'm going to force this by multiplying by a over a plus b plus 1 over a times b over b, right? Forcing a common denominator of ab. So this becomes now, no, be careful, a minus 1 times a, right? And so what I'm going to do is I'm going to keep it as a times a minus 1 for now, right? I might end up expanding it out, but for now, let's just keep it as a times a minus 1 over ab plus b times b minus 1, or b plus 1 over ab. What you can do is just to keep your page kind of nice and clean, and so you don't have to rewrite everything out, unless something's changing on the left-hand side, you can keep it open until it changes. And that's just going to save you a little bit of time and make it a little bit easier to read. So then this becomes a times a minus 1 plus b times b plus 1 all over a b. I haven't changed anything on the left-hand side, but now that I have this common denominator, my next step is going to be to try to get rid of these fractions, right? And so what I'm going to have is I'm going to be able to multiply both sides by AB. So if I'm multiplying it over to the left-hand side, I'm just going to copy out the left-hand side here. So now what I'm going to do is I'm going to multiply this guy over here. One thing that you can notice now, right, you've got a fractions equals a fraction, which we've already talked about, right? But what you can do is you can multiply this over here and multiply this b over here. In this case, I'm not going to multiply this b over here because I already see that I'm going to be able to cancel with this b here. So that saves me a little bit of work. But what I have is I have a plus 1 times ab over b. Now, because everything is being multiplied by b, that's when I can cancel those, just as a heads up. And a times a minus 1 plus b times b plus 1. Okay. So I'm going to show that I'm canceling these by just crossing them out with a different color, just so it's obvious to you later when you look back. But now what I'm going to do, because I'm trying to solve for a, it looks like, because I've got an a in here, an a in here, an a in here, and an a in here. So what I need to do is I do need to expand this all out. So what this becomes once I expand is I get a squared plus a is a squared minus a plus b squared plus b. Careful with your brackets because I'm running out of time. I'm going a little bit faster. So now I need to collect all my a's to one side and all my everything not a's to the other side. So I'm going to subtract a squared and then add a. So what I get is I get a squared plus a minus a squared plus a is equal to b squared plus b. A squared minus a squared, of course, is going to go away, but a plus a is 2a. So 2a is b squared plus b. Solving for a, all I need to do is divide both sides by 2. So I get a is b squared plus b over 2. Great. So this methodology that we used here, where you have to find your common denominator and then have a fraction equals to a fraction, and then solving for whatever variable, you'll be able to use here when you're solving linear equations, right? Something like 24 and 25, 26, 27, 28, all of those, and those are the kinds that I tend to gravitate towards. Those will all be solvable by just finding that common denominator and then moving things around. So on your own, try these, and then that's where we'll pick up on Thursday. There, done, promise. You too. All right. Yeah, if you have any questions, let me know. But otherwise, see you on Thursday. Thanks, guys.